Hello and welcome to this presentation on the Swift programming language. Let's start by giving an overview over the sections we'll be covering. We'll start with basic features, move into history, then move on to a tutorial where we'll discuss the basics of Swift programming. From there, we'll move on to a medium program, and we chose Quicksort as our medium program. Then we'll move on to an evaluation of the Swift programming language's features and share our reflections on learning Swift.
This section is meant to serve as just a basic overview of the Swift language as a whole. We'll go through most of the basic defining features of the language in enough detail to grasp what the language draws on from other successful languages, and also where it seeks to improve upon them as we go. As we go through this section, Swift's features will be frequently compared to the basic features of C++ and sometimes Java. If you understand C++ on a basic level, this section should be easy to grasp. Okay, the intention behind Swift as a language was to create a language based on research into the successful aspects of currently used programming languages. Swift is meant to be familiar to languages such as C++ and Java, but perhaps even more intuitive. Swift has the ability to coexist with Objective-C code, making it really easy to integrate into current projects you have going with Objective-C. As stated by the developers, it's meant to be intuitive, interactive, and expressive, all while maintaining lightning-fast speed. Okay, now we're going to go into data types. So pretty much how we're going to do this is, I'm not going to go through basic features, but we'll just go through what makes variable types in Swift unique, and just where they try to improve upon languages like C++, Java, JavaScript, stuff like that. So as we go, it's just going to be very code-based. It'll just be a small kind of explanation and then an example. So this is basically how you declare different variables in Swift. So if you use the var keyword, then that's saying that you can change this variable you're declaring, and there is implicit typing in Swift. So as you can see here, you don't really have to say that you want x to be an int, but you can, as we'll see later in a second. So var means variable, let means basically global variable in C++ or Java or whatever. So right here you can see that you can explicitly state the type of a variable with a type annotation. That's what the colon space type means. The colon in Swift means of type in words. So also you can use Unicode in Swift, which makes for some pretty convenient variable declarations if you are into that, I guess, or if you speak a different language. Comments are the same as they are in C++ and Java. So floating point values have some extra functionality as compared to other languages. You can actually use scientific notation to represent floating point values, which is kind of cool. Also, to make it more readable, you can pad large numbers with underscores, as you can see here. So that makes for some extra readability, and that'll be kind of a theme in Swift. They try to make it more readable. So down here, this is kind of just explaining that values are promoted, and it kind of works how you would expect in C++. Here we get into the first Swift only, well, I guess they have tuples in other languages too, but this is unique to Swift as compared to C++ and Java. Basically, a tuple is a small user-defined variable where you can stick any number of types together. So, for example, this HTTP 404 error is going to be a tuple of an integer and a string. So the type is going to be int string. So you can do something called decomposition with tuples, and this is an example of that. So decomposition means you're defining the individual elements of a tuple, in this case with status code and status message. So you would be defining 404 and not found as these variables here, and you can use them separately inside your code. If you want to skip over defining an element, but you still want to define one of them, you can use the underscore to skip it. Also, you can access tuples elements with basically indexing notation, kind of like array. So that's kind of easy as well. It's convenient. Optionals are something that are kind of embedded in Swift throughout the whole language. So you don't ever really do this explicitly for most reasons. But if you wanted to, you could. Basically, if a variable is an optional, that means it has the ability to be set to nil. Nil is null in other languages. Right. So in Swift, it's supposed to be made safe, so you can't really... It'll be a compile time error if you try to set a non-optional variable to null. So we'll move on to operators before we keep going through data types, because it just makes more sense that way. So you have your standard arithmetic operators, like the assignment operator, plus, minus, multiplication, division, modulus. All of those work the same as in other languages. Plus is also used for string concatenation as well, like in Java. One interesting thing about modulus, it also works on floating point values, which is a little bit unintuitive and kind of hard to understand at first, but that functionality is there if you want it. So there's a unary operator, minus and plus in Swift, and that just changes the sign of the variable. Other operators, you have all of your binary operators, so your plus equals, minus equals, all that stuff. That works as normal. You've got your comparison operators, all of those work as normal as well. And you also have your ternary conditional operator, which we'll make use of later in Quicksort. And that works the same as it does in C++, where it's basically an if condition and an else if. The nil coalescing operator, that is kind of like the ternary operator. Basically what it is, in this example, it would be, you would do this operation if user-defined colored name is not nil. If it is nil, then you would set color name to use equal to default color name instead of this one, because it would be nil. That comes in useful sometimes. Okay, so this is something else that was new to me. I've seen recently that it's in other languages as well, but it's not in C++ or Java, so this is pretty cool. It's a range operator, which means you just define a range, in this case from 1 to 5. And you have two different kinds of range operators in Swift. One is completely closed range operator. That means that you're including 1 and 5 in this range. And half open range operator would be useful in for loops, like how you would normally set up a for loop. 0 to count would be 0 to count minus 1. So you're not including the last portion of the operator. And then you have your basic logical operators as well, not equal to, and or. So strings have some added functionality. They work just like how they do in Java and C++. It's more resemblant of Java actually, because they have a bunch of predefined methods and properties available. So that works in array notation. And then there's other stuff like insert and remove at, stuff like that. So now we'll move on to collection types. And these are types of data that hold collections of data. Pretty self-explanatory. And in Swift, there's 3 types that are collection types. That's arrays, sets, and dictionaries. So arrays there's not really going to be a lot of explanation here because it basically works the same as in C++ and Java. Again, same thing with strings. It works the same except it has added functionality. So you have your count property, which keeps track of how many elements. You have your insert method, which will insert your argument into the array at a certain point. Append does what it would normally do, what you would think it would do. So just stuff like that. It's pretty intuitive. So we'll move on to sets, and sets are a data type kind of like an array, but it's a little bit weird to think about because sets don't have an order. It's just like a collection of data without any kind of order, for a better way to put it. And it kind of, I guess, comes in handy whenever you're working with stuff like mathematical sets, sort of like that, because it has operations and methods that work like how mathematical sets work, as you'll see here in a second. Right, so we have intersection, exclusive or, union, stuff like that. And here's some more methods. Okay, so now we'll move on to dictionaries. Dictionaries are kind of interesting. It's another new thing for Swift. I don't know if there's any other languages that use dictionaries, but I thought this was pretty cool. So basically a dictionary is a set of data where you have, it's kind of like a tuple, where you have one data type and then another data type, but in this case you're going to have a key and a value. So it will make more sense with an example. So in this dictionary here called names of integers, you're going to have a dictionary of undefined amount, but it's all of the elements are going to be related by an int and a string. So that's how that works. So in this case, it's going to be a string key with another string as the value that relates to the key. And so this kind of comes in handy if you have like a long piece of data that you want to map to like a short name. So in an airport it makes kind of sense. So you'd have YYZ mapped to Toronto Pearson, or Dub mapped to Dublin. So there's some operators that you can use that are for pretty specific reasons. So pretty much you can end up using the key and the value interchangeably. So if you want to print, or if you want to use Dub's value, then you would just say airport array notation Dub, and it would actually put the value, not the key, in airport name. Then you can print airport name, or the value of Dub, which is Dublin Airport. So there you go. That's dictionaries. So now we'll move on to control flow. So again, with this section, we'll just kind of just talk about the differences and the added functionalities that Swift has implemented on top of C++ and Java functionality, because that's kind of the pattern of Swift. So in Swift, we have for in loops, which are for loops in the traditional sense, except with more intuitive syntax. So in this example, you can see that it doesn't read like how it does in C++. It actually reads kind of like an English sentence. So how you'd read it would be for every index in the range from 1 to 5, then you do that. So as you can see, it's pretty easy to understand, pretty readable, pretty self-explanatory. So there you go. Here's another example. You can do it with arrays, because they have added functionality like I explained earlier. You can do it for name in names, and that would go through the entire array. So super easy to understand. While loops in Swift are basically the same thing as while loops in Java and C++. There's small variations in syntax, such as instead of do while in Swift you have repeat while. You don't have to have parentheses or a semicolon on while loops or do while, repeat while loops in Swift. So pretty easy, pretty straightforward. Something that I didn't mention actually that is worth mentioning is that you don't have to have semicolons in Swift if you don't want them. The only case that you need a semicolon to end a statement is if you're going to separate two statements on the same line. If you want to have two lines that mean two different things on the same line of your IDE, then you need to separate it with a semicolon. Otherwise, you don't need semicolons in this language. So switch statements actually kind of focused on a little bit heavier. I guess they felt like they could improve on switch statements, because I guess we all kind of know that they're a little bit tricky if you don't do them right. So they added some stuff on switch statements. You don't have to have break in Swift switch statements. There's no implicit fall through. So if you forget to put break at the end of your case, it's no big deal. What happens is if a case is caught, it does the operations in the case, and then it just goes out of the switch statement. Now, if you want to have that classic C++ implicit breakthrough or fall through behavior, then there's something called, I'll get to that later actually. So other things about switch statements, you can use them with tuples, which can get kind of complicated, so I won't go into too much detail about that right here, but if you want to take a look at this example, you can actually understand it pretty clearly if you know what tuples are. Same basic decomposition rules apply here. They work with ranges, cases work with ranges. And then you have your default statement, which works as the same way in C++. So pretty good stuff. I already said that. Right, this is also pretty interesting. So they have something called a where clause in Swift, which just adds an extra layer of specificity to whatever case you want to catch with your switch statement. So in this case right here, if you're trying to catch two values, x and y, where x and y are equal to one another, then that would be a case where you would use the where. You can have an expression after where that specifies even more clearly what case you're trying to catch, which seems useful. Seems like something that would be pretty good. So one more thing. That would be the fall through keyword. That's what I was trying to think about earlier. Fall through is the equivalent of not including your break at the end of a case in C++. So you get that implicit fall through, even though it's not implicit because you're using fall through, but whatever. So now we're going to move on to subprograms. So subprograms are just simply called functions in Swift. They're more or less same idea as C++ and Java, but there's going to be some pretty cool features that they added. So here's your basic function declaration. This part, the keyword func, is saying that you are declaring a function. Say hello is the name of the function. Person name of type, like I said earlier, person name of type string, that's going to be your parameter name, parameter type. And then the arrow with the data type is going to denote your return value. So that's your function header right there. Pretty intuitive design, if you ask me. And you have your return statement. Yep, that's your basic function. So another functionality that they have is that you can return tuples, which also seems pretty nice. You don't have to worry about what you want to do with like reference pass by reference or anything like that. There is that functionality, but if you just want it to be simply returning two values at once, you can put the two values you want to return into a tuple inside of your function and then return that tuple. And you would denote the returning of a tuple by just saying that you want to return two values, which that's how you'd say it right there. You can define default parameter values if you want to call a function without the entire list of parameters that you've listed. Pretty intuitive design here as well. So in this case, you've defined a parameter in this function, but if you don't define it as an argument whenever you call the function, as in right here, then you're setting that value to 12, which you could use later in the function. If you do define it as an argument, then it's defined, but if you don't, then its default value is going to be 12. Also really nice syntax. Variadic parameters, something that is kind of complicated to do in C++ and other languages, but seems pretty easy here. This is the syntax for it. You just put ... and you're just going to have as many parameters as you want. So you can have one parameter or you can have as many as you want. Super straightforward. Okay, pass by reference has a little bit more, I guess you could say, overhead in this language, because you have to actually do a couple of things rather than just one. That's what the in-out keyword is for. If you are writing your function header and you want it to be a pass by reference value, then you would just write in-out before the parameter name. That's pretty straightforward. The one thing that is a little bit of extra work whenever you're using pass by reference in Swift is that you have to use the ampersand whenever you're calling the function. So that's just a little bit of extra work compared to C++, but they just decided to do that. Okay, so this is a little bit more complicated whenever it comes to functions, but I think it's worth mentioning because it actually makes an added abstraction and control to your programs that I think is pretty cool. So what you have in Swift functions, every function that you define in Swift is going to have a function type. And the function type is defined by the parameter data types and the return type. And this becomes useful whenever you want to work with functions just like how you would work with variables. So let me see if I can find a good example of this here. So you have this function, add two ints, and then you just define a variable math function, and you define its type explicitly right here, and you set it equal to add two ints that you defined earlier. So that works. Now math function is the exact same function as add two ints, which is pretty cool. And there's a use of it. So here is going to be a little bit more further in depth into this application of these. I don't think I'm going to go into this too much in detail, but if it interests you, if you think that would be interesting, it is really worth going and looking at. There's more of that. Alright, so now couple more of these, almost done here with this section, but object orientation is pretty straightforward, a little bit different than C++ and Java, but classes and structures are the way that object orientation is manifested in Swift. So they're pretty similar actually. Structures and classes are more similar in Swift than they are in like C++ and Java. They both can define properties and methods. They both define subscripts to access the values. They both have initializers, which are Swift's version of constructors. But classes actually have the additional functionality of inheritance, type checking, and deinitializers, which is Swift's version of destructors. So here are a structure and a class defined. This is the basic syntax, and it reads just, it's how you would expect for it to be. Really easy: struct, name, define variables, define methods. Super easy to understand. The methods are just defined just how functions are in any other place in Swift. So there's some methods defined. There's some other stuff defined. Instantiation is just as easy as declaration. You just have your name of your class or structure, then the parentheses. If you have a constructor or an initializer, as they call it in this language, then you would put your parameters there. Really easy. So you just access methods and properties how you would in other languages as well with the dot operator. Really not much to say there either. It's really intuitive. That's another example of instantiation with initialization. And okay, we're going to move on to error handling. And this is also really easy because it's really similar to Java exception handling. So if you're familiar with that, then this is super easy. There's only a couple of differences. So to throw an error, you just type throw, then the error. If you want to say that a function can throw an error, then you just say throws arrow, then whatever you want to throw. So in order to, this is just another function that throws and use the try right there. One difference between error handling and exception handling in Java is that you actually have to say it's a do block rather than a try block in this language, and every statement that could possibly throw an error is going to have a try in front of it. So it's a little bit different. And the catch clause is going to be able to catch any kind of error that's thrown if you just use catch by itself.
Alright, so now we get to finally move on to some history of Swift. So in this section, we'll provide a brief background on the development of Swift and its future trajectory in the field of mobile app development. So, Swift was created by Chris Lautner. You might recognize him from some of his other projects, which includes JJVM, Xcode, and Clang, and he is the Director of Development Tools at Apple. Swift began development in 2010, but it was kept mum until 2014 when it was announced at the Worldwide Development Conference. And it was developed as an alternative to Objective-C, with the aim of creating a easy to read and easy to write language for mobile app development. So currently on the roadmap for Swift is Swift 3.0, which is supposed to arrive fall 2016 and includes some interesting new features like interoperability with C++ libraries and availability/portability for other platforms like Android and hopefully Windows. And currently on the TOB Programming Languages Index, it has a rank of 15, a increase from 24 last year.
Alright, so this is going to be a quick tutorial on how to set up a Hello World program using Xcode and programming it with Swift. It's going to be very quick because it's very easy. And just so you know, if you want to download the Xcode suite, you can go to the Mac App Store. You search Xcode. It'll pop up and you just literally will install it right here. Start out going to Xcode and I'm going to just create a new file here. I'm going to do this in Playground. Name it whatever you want. Say hello world. Add 1.0 because I probably have this somewhere else somewhere. Next. Just going to save it over here on the desktop. Alright, now we have a program running. It's called Hello World. And conveniently it already has this set up for us. We're just going to delete all this though. We don't need it. We're literally just going to type print, and in parentheses we're going to put hello world. Close the parentheses, open this console here, and we have hello world printed. If you delete it, that goes away because this is updating live with the code that you have typed. So we wanted to give you some good resources to be looking at when you have questions about Swift. Since Apple did develop Swift, obviously one of the best places to go. Their developer library, apple.com. You go in here, click on whatever platform you're looking at developing on. They have all the documentation you can think of on Swift, Objective-C, iOS, watchOS, OS X, anything that you need. Instructions on how to use the developer environment and Xcode, all that good stuff. And Apple also wrote this book on the Swift programming language. You can go on iBooks and download it. And this starts from the ground up, walks you through the entire language. It starts right here with about Swift and starts with just the var and let, all this easy stuff, and moves you on to more complex things. So those are some good places to get started. One of the things that we also looked at was this course on udemy.com. I'll go ahead and show you that. It's done by Rob Percival. My course is the Complete iOS 9 Developer Course, Build 18 Apps by Rob Percival. Been a very good resource in helping us learn how to use the developer environment in Xcode. This is going to be a demonstration of the quick sort program that we've written in Swift. I'm going to give you examples of how elegant and efficient this IDE is. The fact that Swift is very close to English, very easy to understand, and we'll be able to kind of demonstrate the types of assistance that Xcode provides. And this is what you call a playground in Xcode. It's going to allow us to type up some code live, and then it's going to display results down here in the console. And it'll also give us some information about each line of code over here in the right side of the screen. So this is how we're going to set up the quick sort program. Going to define an array of random numbers, and then we're going to start our function right here. Then we're going to have an if statement that will return to the top of the function if the count of the array is 0, so if it's empty. Then we're going to set our pivot as the first element of the array. And then we're going to pull that pivot off of the list. And then we split the array that's left over into 2 smaller and greater than segments. And then this is where we're going to use our recursion to return each version of the array down the line. And then at the end, we're going to have our end result right here. We'll print it out with the print function. So let's just start off here by defining the array. We're going to use var, and then list. We'll name it list, just like an array in C++. Just going to define it right here. Just put brackets around that. Don't need any semicolons or anything. And now we have our list, and you can see over here on this right side, if we expand that, that is what is in list right now. Now we need to define our function. So we're going to use the func keyword. We'll just call it quicksort. And this is where we list our parameters. So our one and only parameter here is going to be the list parameter. And it is of type int. And we're going to put square brackets around that to indicate it's an array of ints. And then we close the parentheses here. And then there's a very elegant way in Swift that you define your return type. You're just going to do an arrow, which is a dash and the greater than sign, and space, and then we're going to return an array. So it'll be like that. Cool. So now we use a square or a curly brace, just like in C++, to show where this function starts. And now we need to set up that if statement. So we're going to go if list.count. Count is a method. It allows you to return the size of list. So we're going to do if count equals 0. So if the array is empty, do another curly brace. We're just going to return. And that'll stop the function. That keeps us from going into an infinite loop. So right here we have an error. Just kind of show you how this works. You can click on the error right there, and we expected a curly brace at the end of this statement. So that's referring to this function up here. Swift will always give you a way to resolve these errors, or almost always, if it can figure out what's going on. It's very helpful. It keeps you from not being able to find stupid mistakes like in some IDEs that would have been difficult to find, or could have been. And it says down here that we don't have a return. We're going to get to that later on. Alright, so now we have our if statement. If we get an array passed into this function that is empty, it's just going to return nothing. Now we need to set our pivot for the quicksort algorithm. We're going to use let for this one, because that's how you set up a constant. Let pivot equal list element 1 or list element 0. And then we want to pull that off. So we're going to set up this is going to be called list stripped. We're going to strip that pivot off of the front because we don't want to sort that. We want to pull it to the front. List.count again is greater than 1. Then we're going to use the ternary operator. List from range 1 ... to list.count -1. And then for the second option in that ternary, we're just going to do nothing. So we'll set list stripped to nothing. And then when it gets back to that if statement in the next set of recursions, it's going to completely stop the function. And then we'll get our sorted algorithm, our sorted array. So we've got an error right here. Let's see what's going on. It says it's never used. Okay, we'll get that fixed here in a second. So now we want to split up this array into a smaller set and a greater set. These are going to be smaller or greater than the pivot. Smaller equals list stripped dot filter is another method that we can use in Swift. These are all built in. We're going to filter out anything that is less than the pivot. So use 0 less than or equal to pivot. And then we're going to do exactly the same thing for the greater. So copy and paste, switch that to greater, and then we're going to flip this around. We don't want to use the equals because we're going to put the one that is equal to the pivot in the smaller set. Alright, and then now we're just going to return what we got. Return, this is where the recursion comes in. Quick sort. Smaller plus, and this is how we're going to add the pivot point in. Pivot plus quick sort greater. Okay, so what happened here, we wanted to return a type of integer array. And pivot is not an integer array, it's just an integer. So this function, where we typed array right here, and then we put pivot in here, it turned pivot into an array that we could add between the smaller and the greater array, make one array to pass back up into quicksort. Do it all again. So that's it. That's the logic of our program. And now we just need to print out the results. So we're going to do print. Very simple to print out anything to the console. Print quicksort, and we're going to pass our list in. And there we go. We've got a sorted version of our list array. Pretty simple.
Alright, now we're going to talk a little about my personal evaluation of the language. We're going to talk about the three major categories that were outlined in our book, which are readability, writability, and reliability. First is readability, and I guess you probably kind of got my feeling of the language whenever I was explaining the syntax. It's pretty readable, as you can see from all the code that I provided. It's stuff like for in loops and let that make the code read like an English sentence. So, I mean, it's designed to be readable. And as well, it's similar to other popular languages, which adds to the readability. So, there's comments and braces are used heavily in the language, so that all adds to the readability of the language. Writability, the factors that go into readability also go into writability, because the language is designed to fit how you think as a language, or as a English language speaker. So it's obviously the writability is going to be high as well as the readability. And reliability, as Swift says, and evidence suggests that it is reliable as well, because there's type checking, and overloaded variables are also non-existent. If you try to overload a variable, it's a compile time error. It's not a runtime error. And nil or null is also they're really careful about that. So as far as reliability goes, there's extra steps taken for Swift to be reliable and tell you whenever you're making errors as soon as you write them, essentially.
Action.
Alright, finally we get to reflect on our project and on the Swift programming language. We get to share some of our thoughts. I, for one, have really positive feelings about Swift, especially with it being open source. Apple has a history of being kind of proprietary at both a hardware and a software level. A lot of things are kept under wraps, so it's nice to see Swift move in a new direction with that. And Swift as a language is very easy to read and very easy to write, so I think it's a good language for beginners to look into. Now, one major con is that there's not a whole lot available for Windows and Android users right now. But they're currently working on that.
My overall feeling of Swift, and I think all of our kind of feeling of Swift, is that we really did enjoy learning about it, and I kind of personally hope that it becomes more widely used. So I didn't learn all of this for no reason, one, and two, I think that it has some really cool features that I would like to get familiar with without just doing it for no reason, I feel like. So I think that it has some cool stuff, and my feeling is good overall.
As far as my feelings go about the language, I really like how deeply tied in it is to the IDE and the programming environment that surrounds like Apple's ecosystem. It all just really makes sense and flows together very well. As